The singularity functions are a concise way of representing functions that are discontinuous. And this allows us to talk about beam, shear, moment, load diagrams, and slope and deflections, and integrate them continuously across the whole length of the beam without the need to do piecewise integration. A couple things that you need to know. First of all, we're going to denote a singularity function by using angled brackets instead of parentheses. And a singularity function has a pretty simple definition that allows you to program this as well. So if you have a x minus a singularity function, if the quantity x minus a, the quantity inside the singularity function, is greater than 0, then you could just replace that with parentheses and it behaves just like it were a normal expression. If it is less than or equal to 0, then we'll set it equal to 0. And so this allows for example, a load to be turned on and off or to be at a point. The second thing you need to know, since we're going to be integrating these repeatedly, is the integration rule. And likewise, this behaves differently if n is less than or equal to 0 versus greater than or equal to 0. Now, the key thing is whether we have the exponent ends up in the denominator. So if it is less than or equal to 0, then we don't have the pre-multiplier. And so if it is greater than or equal to 0, then we will use the pre-multiplier. So let's take a look at what how that behaves in a couple examples. So if we're integrating the singularity function of x minus 5 to the minus 2 dx, we would integrate that, and as usual, the minus 2 becomes a minus 1. However, we would not divide by the minus 1 as we would for a typical integration without a singularity function. However, if we're integrating, if we have that same thing raised to a positive 2, now this will become x minus 5 to the third over 3. So you could apply those integration rules. With that information, you could do any of these. So you'll note here that both of these conditions apply at 0. And that's because you get the same answer either way. And so it doesn't really matter what you do when n equals to 0.